Okay, so now we want to look at calculating the y-intercept. So to calculate the y-intercept, that's when x is 0. I'm going to evaluate and simplify the equation, and that will give me my y-intercept. So what I want to do is I want to say, well, y is equal to, so in this case, because I want the y-intercept, x is 0. So in place of x, I'm going to put 0. So I'm going to evaluate the bracket first. So I have 0 plus 2 is 2. 0 plus 4 is 4. And then I can do 2 times 4, which is 8. So it means the y-intercept on my graph is at 8. So let's graph these. So they've given me this time the x-intercepts, the vertex, and the y-intercept. So the x-intercepts are at -2 and -4. The vertex is at -3 and -1. And at 1, 2, 3, 4, 5, 6, 7, 8, there's a y-intercept. But I'm missing the point over on this side to make this work, because right now all I have is this. Well, the nice thing about a parabola is it's symmetrical. So if I look, from this x-intercept I went over 2 and up 8. So from this x-intercept I'm going to go over 2, and I'm going to match that point over here at the same distance and space. So now I have those points, and I can join them together, and they create a parabola. Let's look at another one. So I want to calculate the y-intercept, so I do that by changing x to 0. Now I have y is equal to 2. I have 0 plus 1, which is 1. I have 0 plus 3, which is 3. And now I can multiply 2 times 1 is 2. And then 2 times 3 is 6. So my y-intercept is at 6. So what I want to do is I want to now put all these points on my graph. So my x-intercepts are at -3 and -1. So -1 and -3. My vertex is at -2, -2. It's always halfway between my two x-intercepts. And my y-intercept is at 6. So 1, 2, 3, 4, 5, 6. Again, I don't have this other point over here to make it symmetrical, but I can see I went over 1 and up 6 from this x-intercept. So I can do the same thing. I can go over 1 and up 6, and I can match that point to make it symmetrical. So now I can graph all 5 points, and I'm good.